Water. Ah. Not just a refreshing beverage on a warm day, but a critical component to all life on Earth. But where did the water around us come from? Over 70% of Earth is covered in water. Very broadly speaking, this water could have come from two places. It was either there when the Earth formed originally, or it was delivered later from space by meteorites, asteroids, or comets. Because meteorites can contain up to 20% water, and comets are much wetter than that, it doesn't take too many meteorite or cometary impacts to provide the 0.02% of Earth's mass that is currently water. Scientists have long thought the Earth and Moon were formed following a giant impact between two planetary bodies. This impact is argued to have resulted in a substantial loss of volatile elements on Earth and Moon, so that in order to account for the water on Earth, additional water from meteorites, asteroids, or comets has been called upon. However, newer research shows that volatiles are not always lost during large planetary collisions. So, water could have survived the moon-forming impact. Was it just a few chance encounters with soggy flying rocks that provided most of Earth's water? Scientists have compared Earth's water with that of comets and meteorites by using isotopic signatures of the hydrogen and oxygen in water. So far, extraterrestrial materials do not really match Earth's water. We decided to take a different approach by looking at rocks from the moon to attack the question in a new way. We studied some of the first rocks that formed on the moon after it cooled. These lunar rocks are essentially devoid of water, so instead of looking for water, we investigated the volatile element rubidium that radioactively decays to the refractory non-volatile element strontium. We did this because rubidium behaves similar to water in meteorites, but contains time information about volatile element history. The isotope rubidium-87 decays to strontium-87. So, the amount of strontium-87 records the total amount of rubidium that was present in the materials from which the moon formed since the beginning of the solar system. From that, we infer how much water the Earth formed with. We noticed that the moon had built up very little strontium-87, so the materials from which it was derived were never in contact with even modest amounts of rubidium. Thus, loss of volatile elements was not why the moon was dry. Instead, the materials from which the moon formed always had very little rubidium and probably water. Geochemical modeling of the giant impact further indicated that the materials Earth formed from were also depleted in volatile elements. Thus, it is possible that the Earth and the Moon were born with roughly their current amounts of water. While this research does not preclude additional water being added to Earth after the giant impact, it demonstrates that additional water is not required, and that if any significant water was added, it probably came from comets and not from asteroids or meteorites.